The next question, you have the count rate from a sample of radioactive material. Measure every 20 seconds for 2 minutes. Result has been corrected. So, okay, we have this count rate over 120 seconds. Suggest one possible source for this background radiation. Okay, just name all that you know. Rocks, radon gas in atmosphere. Okay. Can also say from building materials. Building materials. I'm just going to name 3 here. You just need any one. You can just say rocks if you are comfortable with it. Alright, next. From the table, without attempting a graph, estimate the life of the radioactive material. Half-life of the radioactive material. If I were to take the 280, half of it will be 140, will be around here. So I'm going to put it as 50 seconds. Without attempting a graph, that means not drawing a graph. So the answer is just 50. I'm just going to write 50 inside here. Okay. This one I need a big one. Okay. Okay, firstly. Or first, not firstly, first. Describe experiment to prove that no beta particles or gamma radiation are emitted. So basically, you want to prove that only alpha is involved. So first, maybe I'll just want to draw the diagram first. Where's my pencil? Okay, let's draw the diagram. If I would obviously need the source. Okay, in the lead box, that's how you look. I will need a piece of paper. Then I will need the receiver of the Geiger-Müller tube. Then leads this to the counter. Okay, with all the counters. Geiger-Müller. This is okay, can call this GM tube. Then this is the paper. Okay. Alright, first thing, we're just going to measure the background radiation. Then put the source in front of the receiver of the GM tube and measure. Okay, don't measure, read the counter reading. Next, insert a piece of paper in between the GM tube and the radioactive source. Okay, and take the reading again. It would show that the reading drops drastically to the background radiation level. Thus, it is proven that the source only contains alpha particles. Okay, and we have done our 2 marks. Okay, 50-second shifted upwards. Okay, next. State one precaution that should be taken for safe handling of the material. Since it's alpha, so maybe you should always wear glove. Always wear glove when handling. That's a good enough one because you will not be able to penetrate the glove. Okay, next we have this Hiroshima bomb. What is meant by nuclear fission? Okay, I think that's quite easy for all of us, but why did he come back here? Okay. What is meant by nuclear fission? It is the splitting of radioactive nucleus into two or more smaller nuclei. With I think don't need to release, just like that. Okay, just like that. Okay, if asteroid 2023DZ2 were to hit Earth, calculate the energy equivalent of number of bombs dropped on Hiroshima. And here we go. The next question. Okay, we have a radioactive isotope iodine 131. We want to find the volume of blood in the patient body. Okay, you have your atomic number 53, 131, beta particles, and gamma ray. Okay, so we have here, we need to fill in the blanks. 131 to 53. Now, beta, as we know, is not in the nucleus, so on top is 0. You will minus the proton by you will minus 1. So the proton number will actually xenon by emitting a beta particles. So instead of decreasing, it should increase. Okay, and there should be no change in the mass number. The mass number will remain the same because one neutron will actually become a proton and kick out this this electron. That's what is actually happening. So this is it, 131 and 54. Okay, again, what is a half life? State what is half life? The time taken for half the mass of a radioactive radioactive substance to decay. So you have this. I'm going to choose 4,000 and I will take the 2,000 as a mark. What color should I use? Red? Okay, red is good. Oh, it's blue. Let me change to red. Please use a ruler in your exam. I can't use a ruler here, so this is 12. In the working, I'm just going to use a pen. We can do is half life. So it's just 12 minus 0 equal 12 seconds. Okay, so answer is just 12 seconds. You can pick any other points. Whatever answer you get, as long as it makes sense, you should be given the marks. Okay. Next question. Sodium 24 and 23 are two isotopes. Once again, we fill in the blanks. Emits a beta and produce a nucleus of an isotope. Okay, so by just consider the beta first. Again, minus 1. Then your magnesium will be 12 because you should become, yeah, 12 minus 1 give you 11. So this is 12. 24, you will stay at 24 because a neutron becomes a proton, but the total number of particles inside the nucleus remain the same, so it stays at 24. Okay. Beam of beta, as you know, beta is negatively charged, so beta will go towards the positive side. It will do this. Okay, and then maybe don't let it come out. I don't, because once it touch, it will already neutralize. So it will just be like that. And for gamma, it will not be affected at all. Okay, how am I going to draw my straight line? Very hard to draw. Okay, straight line. Okay, I have done this. That's 2 marks. Next. Explain why the path taken by the beta particles differ from that taken by the gamma ray. Uh, Beta particles are negatively charged and will be repelled by the bottom negative plates and attracted by the top positive plate. Thus, there will be a, an upward trajectory. Upward. Okay, let's not use such chim word. There will be an upward force on the beta. Gamma particles are uncharged and thus not affected. Okay, and that's my 1 mark. Okay, let's look at this question. 2 marks. I want to make 2 points. Number one is The half-life is long enough for doctors to make measurement. Okay, the half-life of the sodium is long enough for doctors to make measurements. And at the same time, it must be short enough so that the body does not receive too much radiation. And half-life is also short enough so that the body is not being irradiated for too long, for a long time, for too long. Yeah, don't want you receive too much radiation. Okay, 2 points, so 2 marks. Okay, next. Carbon 14 is an isotope of carbon. Radioactive age decay is 6,000 half life. Okay. Wow. We need to mark this. The count rate. It draw a graph. Whoa. The initial count rate is only marked for X. Okay, so for 16, 1006. I need a pencil. Where's my pencil? So at 800, where will it be? It will be 6,000. So you will be in the middle here. Middle here. For what? 800. About here. 6,000 is here, right? This one. Okay. Then we must continue. At 800, then we divide by 2 again, 400. 400 will give me another 6,000 years. So 1200 at 4,000. 200, we will add another 6,000. So it's 18. Touch I hope I'm marking the right square rectangle. Okay, it's a bit hard for me to draw here on the screen. I'm trying hard not to draw a straight line. Oh, okay. You get what I give. You all get a div. So if 800, you also go that big. Okay, something like that, but make sure you draw nicer than me in the exam. With a curve rule, if you really cannot. I'm very hard for me to draw on the screen. Okay, given that the count rate of the sample of wood is 500, use figure 8.1 to determine the age of the sample of wood. Oh no, 500 is about here. Okay, I'm just going to dot over, but I'm going to use a different color. 500 is about in between this. This is so hard to draw here. This is about, I just put it at 9,000. So yeah, 9,000 years. I mean, if your graph is drawn very badly, then yeah. So it depends on your graph. So mine, I think, is drawn very badly. So maybe you might have a slightly different answer, but it shouldn't differ by more than 1,000 years. Should be between there. Actually, 600 years should not go too far away. Okay, next. Okay, we have a GM tube, 10 cm away is counting as 800, and then with a piece of 5 mm thick metal, it is 200. Now this one should only be able to block beta and alpha, so it should still be receiving gamma. Wait, let me see. No, this is this. another source. The reading has been corrected. Okay, okay. So background should be 0. So this is only due to the source. So beta and gamma. Explain how the reading show that the source emits beta and gamma. Why not alpha? Without this is 10. Oh, I think I know why. Okay, fine. I know why. It's almost a bit lost. Okay. Okay, first reason, beta particles are absorbed by the 5 mm thick metal plate. Okay, metal. Thus, there is a significant drop in reading or in count rate. Okay, some more. Uh, Gamma can pass through the metal, the 5 mm metal. Therefore, there is still a count rate of 200. I think what they want is they didn't really want us to say that there's no alpha, but it want to show that it did emit beta and gamma. Yeah.